By removing the connection in an instrument amplifier, which we're going to look at in a second, between the resistors in the first stage and ground, the common mode gain for the first stage can be reduced to much less than 1. Now, is this true or false? Well, common mode rejection ratio is our CMRR, and we have formulas for it right here. These can be found in the description link below the like button, where we have our gain right here, and then we have it in decibels. We see that the CMRR is a measure of how well we achieve our goal of making the gain for differential inputs much greater than the gain for the common mode inputs. So ideally our ACM is equal to 0, so the CMRR is equal to infinity. For practical circuits, our CMRR can be very high, but not infinite. CMRR is typically limited by how well devices match. In the difference amplifier, the ratio of R4 over R3 must match our R2 over R1. CMRR for op-amps typically depends on the matching of devices inside of our op-amp, so like the transistors and resistors inside of it. And then we have an example here, but we're not going to be looking at that. We're going to be looking at our instrumentation amplifiers. So with our instrumentation amplifiers, we have this right here. They provide a much higher CMRR, which again is the common mode rejection ratio. It provides a much higher common mode rejection ratio and input resistance, but it requires additional op-amps. In this version, the first stage gain is the same for VIDM, which is right here, and we calculated that previously. These are also in the notes linked below the like button, something like this, right? So we have that VIDM up there, and it is much greater than, right? So we calculate for our VIDM and our VICM, and if we make our V2 and V1 the same common mode voltages, it will be the exact same. So we see that right here. Next, if we look at this drawing, which is the same thing as the previous drawing, we just removed this grounding in the middle and we combined the two resistors. We see we have R1 and R1 right here, and here we have 2 R1. So the previous drawing just combined the 2 R1 and removed the ground. Much lower common mode gain ratio, so we have our ACM here. It can be achieved in the first stage, and therefore we have a much higher CMRR, just by removing the wire between our node X and ground. So in the new version we have here, the first stage gain for our VIDM is the same as before. However, the first stage gain for the common node voltage, or the common mode voltage, which is VICM is the common mode, it's reduced to only 1. And so this, our question here, is saying that it is reduced to be much less than 1. But here it's saying it's just reduced to only 1. And so that means that this statement is false, and we should replace this with by removing the connection in an instrumentation amplifier between the resistors. Again, that is the ground right here, that's the connection between the resistors in the first stage and ground. The common mode gain for the first stage can be reduced to 1, and that's right here in the notes linked below the like button.